You're live.
Hello, Internet.
Hold on, let's where's my tweet deck? Tweet deck.
Internet. The interwebs.
Internet, go.
All right, Chris, it's time for your Sathi impression.
No.
Millions and millions of devices.
I learned my lesson.
Using
I learned my lesson on
millions
this
and
side
millions
impression.
and millions of web pages to record a podcast.
Well,
Or
that's not even
devices.
what he says. It's soothing. It's about the future of Windows.
All the future of .NET Standard and Core. We're just not sure which one's which. There's Core and there's
I
Standard.
want people to go from using Windows. What? Needing Windows?
Did you say needing Windows to
Loving
Using
choosing Windows to love.
loving Windows. All right.
Oh, and
All
here's
right, are we
Bash.
good? Yeah, are we?
Here's
We're,
Bash.
we're good, right? Should we just go? We don't even have to
Yeah.
like synchronize. I can just click a button. This is amazing. Are
So
we good? Any reason not to start?
Are we not
No,
doing
exactly 11. Look
Are
at
we
that.
wanna-
doing Destiny?
No, don't worry about. I don't know. Don't worry about Audacity. I'm not going to be recording in Audacity.
Yeah, I think we're taking fate. All right, yeah, you just hit record when you're ready.
All right.
3, 2, 1, contact.
There we go. All right, cool. Hello, and welcome to the Static Void Podcast. I'm Jess Chadwick,
I'm Todd Snyder.
And I'm Chris Gomez.
and we are your hosts. We're recording this on the evening of May 8th, 2016, and tonight we're happy to have a special guest, Matt Hornsby. Matt is an experienced principal software engineer who has led teams beyond... God damn it. Matt is an experienced principal software engineer who has led teams building internet-scale applications such as healthcare... Are you kidding me? Such as healthcare exchanges and retail websites that are among the largest in the world. This led Matt to develop a passion for guiding his teams to build maintainable systems and write quality code. Sounds like my kind of guy. That's why we brought him on the show, right? Tonight, Matt has joined us to talk about a concept he calls code sprawl. So, Matt, welcome, and thank you very much for joining us. We're really glad to have you. So tell me, what the heck is code sprawl?
Yeah, hey guys, thanks for having me here. It's an honor to be on here. I don't know. For a long time, I've been sort of looking at code, but not code for itself, like almost like a metacognition kind of thing, as it pertains to software. How code maps to the way that we think about problems, like how we cognitively think about problems, why things evolve the way that they do in software, and just generally, what can we do to improve, the overall quality of software and understand why things rot over time. And what this sort of led me to think about was there's one of the guys I like a lot who's an interesting thinker in this field is a guy named Arlo Belshi, and he's been really sort of influential to my thought process and thinking about how code sort of evolves and what it means to write good code. And he sort of introduced me to this idea of the M-shaped person. A lot of people we've talked about like the I-shaped person. That's the person who has like deep domain knowledge in one specific area, but it's not very wide. So it's sort of in the shape of an I. And then we talk about the T-shaped person sometimes. So that's somebody who has a deep knowledge in one domain, and then they're able to talk across the top. So you get a couple of people together that are sort of T-shaped, and they have the common language to talk across the top, and maybe naive language, but you can go up and down these stacks because the people can communicate across the top. So and what Arlo mentions is this idea of like the M-shaped person, and that's a person who is able to have these sort of multiple domain expertise in one mind. So there's not context switching, there's not the communication gap talking between two people that have some different domain knowledge, but you're doing it at the speed of thought. And the thing that I found really interesting about it was he mentioned that when you have people that are like that, you can think very quickly across these different domains, and you can sort of creatively or accidentally misapply concepts from one domain into the other domain. And that's where real innovation comes from. It's thinking about two things that you've never put them together before, right? I don't know. I'm really into woodworking. I like woodworking. I like sailing. Are there concepts that I can put together that go from one to the other in sort of weird ways that you wouldn't put together? So that's sort of a long-winded way of saying how I think that I got here to start thinking about this idea of code sprawl, which comes from the idea of urban sprawl and the way that towns and cities have sort of sprawled out into suburbs and beyond over the last few hundred years. And so it was sort of a realization that as code ages, it sort of seems to follow similar patterns to how civilization ages, and how as we get more and more people, we try to pack things together, we end up with a lot of very similar kinds of patterns in code as well. So that led me to do a little bit more thinking and some research on this, and it turns out there's a lot of kind of concepts that map into that domain pretty well. So one of the interesting books that talks about this is a book called the Sprawl Repair Manual, and we can put a link up to that later. But in it talks about different generations of urban sprawl. And I saw that there was, as I was looking through it, I was like, man, this sounds really similar to the ways that especially enterprise or large-scale software tends to sort of evolve over time. So
in a way, one of the things it sounds like we're saying is that the way urban sprawl occurs, we can scientifically define it. It's not necessarily a choice. It's a natural evolution, and then you're seeing parallels in our code bases.
Yeah, I think that's a good way of thinking about it. You know, when we look at these different generations of urban sprawl, you can sort of think back to pre-car, like pre-automobile, and even before trains were invented. Think back to, you know, medieval times. You had kingdoms that they had a tight urban core. Everything, all of the commerce, you lived and worked in the same place, and you could walk everywhere, right? Everything was in this tight urban center, and everything was in there. You couldn't go that far outside of it. You had countryside, and you could get places via, you know, horseback, things like that. But general day-to-day living, everything was in this tightly packed, dense urban core. So in this book, The Sprawl Repair Guide, talks about this first generation of sprawl as being when rail cars were created. And now you had this tight urban core with very distinct like railway paths. And you could get from place to place. You could start moving outside of the urban core, but you still had very, very well-defined paths that you would go through. And you would find that smaller communities would build up around the railroad stations. It still wasn't gigantic towns. It was some of the services that used to be in that tightly packed urban core started to migrate out, and you'd have these small communities that would pop up around the railway stations. So, you know, maybe some small, you know, groceries, stores, things like that would pop up around there. But it was still, you couldn't stray very far, if that makes sense. There was not really any sprawl yet. It was very well thought out. The way that you would get from place to place was still very tightly bound by how the railroad system was more or less designed, right? So the way that I thought about that in terms of what that looks like in code, this is sort of your well-defined, like, cohesive urban core of of cross-cutting concerns, things like that. You don't have duplication everywhere. You have very well-defined messaging flow. There's not a lot of copy paste. It's just everything is. This is your when you first start off with a good project. You get to have the architecture looks great, design looks great. You haven't run into any of your edge cases yet. You haven't run into your business partner saying, "Oh, what about this?" and having it slightly just chip away at that. So this is sort of like the railroad stations where it was well thought out, sort of planned message flows and architecture. You still have this urban core of your data access layer, if that's how you architected it. Your logging, all of your stuff, sort of still in this dense urban core, and your messaging flow looks really good. There's nobody going around your design at that point, if that makes sense.
Is this also maybe when there's less people involved, like a couple senior folks are kind of brainstorming the thing?
Yeah, I think that's probably, I hadn't thought of that, but I think that's a great way of thinking about it, because there's still not a ton of people involved. It's not that you have to get a few people here and there, in sort of the physical manifestation of this first generation of Sprawl. But yeah, I think as you add more people, you add more developers to the mix. I think one of the interesting things is, like, I feel like software is a manifestation of how the author of that code mentally maps that problem, how they think about the problem. And we all think about the problem totally differently. I've run experiments on teams before where I set out and say, here, solve this really easy problem. I want to see how everybody does it. And even for very simple things, it was always very surprising to me to see just how differently people thought about a problem. And really, when you look at somebody's code, that is a map of their thought process. And it's a mental model of how they approached a problem. And I think, for me, that is one of the reasons why everybody's code sucks but mine, right? Because I think about it differently than you guys would.
Yeah,
and
totally.
Yeah.
Right? So part of it is that when I look at someone's code, it's good if it looks like how I would solve the problem.
Yeah.
And it's bad if you think about it a totally different way and solve the problem a different way. So
Yeah. Well, that's why I think that the code review is very important to actually talk to people, right? It's not a code review is not I sit there and I look at your code in isolation. It's I have a conversation, right? We bring it up and we talk about it. What was your thought process? How did you get to this point?
Yeah, that's dead on. I mean,
Yeah.
because we have to be able to communicate why we solved the problem that way, and I think the code review is an essential way of doing that.
Yeah, I have a similar conversation with my team where I put up two blocks of code that are exactly the same, and on the right I say this is bad code, and on the left I say this is good code, right? And I say the difference is the thought process, right? Did you go and did you research and find all the different ways to do this, or did you just throw it together and it worked and you just moved on, right?
Yeah, and it's funny that way, and you even see it in real life. I've had conversations or arguments with girlfriends and stuff like that in the past for dumb things like how you load the dishwasher, right? Like I think of it as like a pre-sort algorithm. Like as my hand is moving down, I'm pre-sorting each piece in there so that when it's done, I can just pull it out, right?
Yep.
And I've had people that are like, no, that takes too long. I'm just going to put it wherever there's space.
Yep.
The water's not going to get in there if all of these pieces that are alike are sitting right next to each other, right? So,
my wife and I have gotten to the point where if one of us starts loading and then walks away and the other one comes, we just have to undo it. Just completely remove everything and start over again. Both of us.
Yeah.
Yep.
So it is about process, right? And your process is correct. I mean, I think about how I unload the cart at the grocery store, and I actually cold things I want to keep together and things that are in boxes I want to keep together. And I honestly think my wife is just like, unload, whatever. And to be honest, it's all going in the same trunk anyway, so why am I doing this? I don't know. I just have this compulsion to be like, there's an ordered way to put this on the belt.
Yeah, it's so, I mean, a lot of the stuff just, it transcends the code. It's just really about how we're thinking about a problem, and that's all software is. We think of ourselves as being like very technical people. We use the word engineers, things like that. But really, most of the people that are in this industry for a long time are just problem solvers, right? We're people that like solving problems, and software just happens to be this really malleable way of doing that. So, but we all think about it differently. So
Yeah. So like compared to urban sprawl, is the scary thing that us as software engineers have the power to basically just pave out a new road without talking to anybody.
Yeah.
Just saying, look, I just built a new side street and I decided to put a condo there. I know that nobody else was thinking about that, but oh well.
Well, yeah, I think there is a really big component of that. When you start moving into the next generation, past the train being created, the automobile really it transformed the American landscape, and things started becoming subordinate to automobiles. It used to be that the way that you built things was subordinate to people getting from one place to another, but when the automobile was created, it now for the first time allowed you to go from any point to any other point. And because of that power, everything started building up around that. You had roads everywhere. You started seeing buildings that had gigantic seas of parking lots and pavement, right? It changed everything. It changed architecture. It changed the way that we go about our lives. And it eventually allowed us to now stray from that urban core for the first time and get away from it. And so what you started seeing was new highways and interstates. You started seeing car-dependent sprawl around these new highways. You could now no longer walk to the grocery store. You have to drive to the grocery store, right? Communities and like residents now, like I mentioned, they sort of became subordinate to automobiles. And the way I think about this in code is like you said, Chris, it's lowered cohesion. It's difficult to follow messages. Now you can get anywhere from anywhere. You don't have to follow the train route. Like you don't have to go to the train station and get on to get to and from the places. And because of that, there's no like cohesion around how all of the commercial sites and places and parks and everything that you used to go to, they can just sprawl everywhere now. So actually, what I think of this is that you start seeing code duplication, and not just code duplication, but concepts being duplicated in different parts of the code base, partially because you don't know about that it exists somewhere else, but also because it's easy. And you start seeing that these concepts diverge over time. And I sort of think of it like strip malls in a way. Every strip mall is basically the same thing. It's the collection of a bunch of stores, right? And they follow very similar like architectural constructs, but they diverge a little bit over time. So you have this sort of like clone stamp communities. I grew up in Southern California. You go over there and excuse me. You go down there and every town is the same exact thing. It's stamped over and over and over again for hundreds and hundreds of miles. And it's sort of, a lot of places, it's sort of ugly and soulless and uninspired. And I found that code sort of follows that route sometimes. And, I've talked with people about this before. This is where you start seeing the introduction of things like inversion of control containers. You start seeing a lot of practices emerge around like dependency injection and stuff like that. And when you start seeing that, that's one of the areas in code where you start really seeing a lot of this sprawl. The messages that are flowing around the system are now no longer able to be followed easily. All roads lead back to your DI container, right? And you bootstrap everything at the beginning of an app, and then if you ever want to trace where messages are going, it all flows back to that the IOC container in there. And so that's sort of where I start thinking about the parallels in that sort of second generation of sprawl.
So Matt, earlier on you mentioned something about the idea when you first start out on a project, things are clear-cut. You have a clear set of use cases, and someone introduces a new requirement or they want to change something. Is that one of the cause of code sprawl? all of a sudden now I have to handle a different use case, slightly similar, but there may be differences.
Yeah, I think that's a lot of it. I mean, if you thought about the earlier example of like a train station and a train route, like what happens if somebody said, "Hey, we want you to we know that you have this train station that goes from here to Los Angeles or whatever, but what if we want to go to San Diego instead?" Like, now what? Now do you have to? You can't. Like, there's not a real easy way to do that. But software is so malleable that we can. Like, we can just duplicate things. We can create, separate branches in the code to do different stuff. It's so easy. And I think one of the things that we can talk about later is this idea of there's human cognition. Like, our working memory is so small when you think about it. There's that whole magic number that tells about how many things that we can keep in our subconscious mind all the time, and it's like, I think it's 5 plus or minus 2, something like that they talk about. And
Yeah, right.
there's a related psychological phenomenon that is fairly fascinating. And the idea is that what you see is all there is. And what this is that whatever's in your mind, like if you are sitting there thinking about a problem, or you're trying to understand an architecture or design of code, you think that at that you have all of the knowledge that you need in your mind in order to move forward and make decisions, but you actually don't. We know that there's only so much that you can fit in your working memory, and the insidious thing about it is that you feel like you are bringing all of your knowledge to bear on it, and you're just not. So there's this sort of mental house of cards that you need to build up, and you have to be very, very diligent about the cognitive overhead that you are placing upon people when they are reading your code.
Mm-hmm.
And so that's where the sprawl thing really becomes a problem. When you start having these meandering message patterns, you don't have a clear-cut architecture anymore. You're placing a huge burden on the reader, and you fill up their mental house of cards quickly, and that's all they can keep in there. So you think that you have this whole thing built up in your mind, but you don't, and you don't even realize it. So you're making decisions based on knowledge that you can't possibly have at that moment because you already paged it out.
Yeah.
It's your interpretation of it.
Yep.
You're basing decisions on your interpretation, which
Yeah,
can lead to lots of problems in software.
Yeah, so I mean, what we want to do is we want to leave breadcrumbs. We want to build our architectures and designs in ways that even if you're not able to keep it all in your mind at once, that there are aggregations and there's patterns and things that make it very easy to understand what's going on. So there's patterns that you can use in your code. One thing I really like is to make sure that the actual, like the file system itself, says something about the design of your code. So I don't even have to open your code. I can look at a layout of your code base, and without opening any code, I can understand the concepts in the system and a general design, a general architecture of your system. And
That's even the naming of the files then.
it's a big part with naming of the files. I've talked with Chris about this pattern a lot that I really like for certain types of software development, and it's the mediator pattern. It's one of the Gang of Four patterns, but what I like to do, if you take your basic ASP.NET MVC app where you have a controller and the calls are coming into that, and then you're going and talking to some backend model or backend data access layer or whatever to get your answers. The pattern du jour, it seems like for the past, 5 to 10 years has been the repository pattern. So you create repositories that model some section of your code, and it's usually built around some entity like customer or order or whatever. You have an order repository, and then you have these order DTOs, and you've got mappers that go back and forth, and it's that's been the way that we've been sort of building software for a while. But I find that it doesn't really communicate anything about your system. It doesn't communicate anything about the queries that you're utilizing in the system, or the commands that you're sending through your system. And so I think of a query as any time that you are asking for information to do something with, to do calculations on. And a command is saying, hey, subsystem, please do something on my behalf. And so there's a lot of talk about how we do command query segregation. That's one of the things that we talk about sometimes in design. And so I actually like to model that with the way that I write classes, is create a class called customer order query or whatever. And that is now a file that you just look in the file system, and you can see I've got a directory that has queries. It's just queries. And you look in there, and it will tell you every query that is important to that system. And you don't even have to break open code. You know at a basic level sort of what's going on. Same thing with commands. Like if I want to do something like, say, purchase shopping cart, I can have a purchase shopping cart command that I send off to some subsystem that deals with it. And you can see it right there in the application directory without knowing anything, without breaking anything open. And so that's one that I found that really helps to keep the amount of stuff that you need in your head a little bit lower.
So you mentioned, I might be getting onto the wrong aspect of this, but you mentioned that you'll have a folder named queries or a folder named commands. So that's actually how you would organize your project. You don't apply any kind of domain organization, like you had mentioned orders, right? There's no orders folder under which you have commands and queries, or there is.
No, I think that's a great call out. And what I try to do with it is, in a simple system, you may have a handful of queries, and so you can fit them all sort of in one area. But if you start getting bigger and bigger, and you see that you have these sort of aggregates or these sort of bounded contexts, if you're talking about like the domain-driven design parlance, then sure, group those together. You might have queries and then orders, and then you might have all of the order queries underneath that. But the key thing for me is that don't make me think. Like, if I can look over and I can see this directory structure, I know something about the design, and I know something about the important concepts that are happening in the system, without having to dive in and dig through a bunch of esoteric stuff that I've never seen before.
Well, I think it is true that when I open a project for the first time that might be anywhere from 6 days old to 6 weeks old to 6 years old at work, right? What do? I start cruising through Solution Explorer, and I'm just opening folders if it's been put in folders. And one thing we can do in our world in .NET is put as many classes as we want in a file. So maybe the Java guys are forcing that a little bit because you can't. And it can be both infuriating. It can be infuriating when you realize that a file that maybe is, like you said, it's on the surface, it says that it's an order query.cs, and then you open it and you find 5 queries in there. But then on the other hand, I'm guilty of it myself, where I say, well, here's a little helper class that it's only really helping me get this job done, so I'm not going to break it out. Which is probably famous last words, right? Or maybe I'm doing something wrong to begin with by writing that.
Yeah, right. Separating your domain by putting it all in one file.
Right.
With regions. Don't forget to use regions.
Yeah. And it's not even, we've been taught that it's bad, like one class per file, but there's a lot of times where it actually makes sense to combine them together. And it's all about, for me, it's all about reducing the cognitive overhead of understanding and consuming the code. So that's what number one thing when I'm designing something, if there's not some other completely overriding concern, like right now I'm working on something where the number one thing is it has to respond in crazy quick times. So that's the number one concern. So it changes the whole architecture based on that. But when things like that are not present, it's all about the cognitive overhead, and that overlays and begets everything. It begets maintainability of the code, the overall your overall ability to just comprehend what's happening there is so important, I think. So, one of the other things I think is interesting. There was a British anthropologist named Robin Dunbar, and she or he, I'm not sure which, came up with this idea that there's only a certain number of stable relationships that you can comfortably maintain, and this is more about sociology. So they came up with the idea, and this was based on the size of a primate's brain. So that looking at human brains determined that we can only comfortably maintain about 150 stable relationships at any time in our lives, and it just gets too complicated after that. And so the interesting thing about that is you see that there's that when you start getting above this number, the idea is that it generally requires more restrictive rules and laws and enforced norms to maintain stability in like a cohesive group after you get too big, right? So you have to start enacting laws. You have to start enacting coding standards, design standards, things like that when you start getting too big. And I think that you also look at, I think I read this in Malcolm Gladwell's book, The Tipping Point. He mentions that there's this this community that I believe they came from the same origins as like the Mennonite and Amish folks. They're called Hutterites, and what they do is when they get to that number, 150, they split their colony. So they actually go and create a daughter colony, and they start over. They take some people from that one that was successful, and they move it somewhere else. And it was for this very reason that, like, as your graph, your social network gets too big, it's no longer a tightly knit, cohesive group anymore. And to me, that's like Facebook. Like when I had 5 friends on there when it first came out, I was way more loose with what I would put on there. And now that everybody is on there and it's so visible, I hardly use it anymore because it just it doesn't feel like a group anymore. So that's another one where I think that sort of concept, we can apply it to our code, and we can essentially say that when you have too many relationships, too many classes, or too many ways that you have code over here talking to code over here, that it becomes unmanageable in our tiny brains that we have, and you have to split it up, and you have to put things together in ways that they can stay cohesive and not completely overwhelm you and make it so that you have to put these extra rules and standards and things like that in place to keep order.
So I'm sure that all of us have different capabilities, and what happens when you have either the senior person, because of experience or maybe just because they're brilliant, is capable of more in their head, but yet the rest of the team has to keep up? I mean, what does that do? Does that have an effect on how the code sprawls? Or just it means that this senior guy is asking us all to operate without a map, but he's got it clear in his head?
I think oftentimes the senior guy is the guy who wrote a lot of the code, so it makes sense to him. But also,
that's the way he would do it.
Yeah, I mean, it maps onto his mental model of how he solved that problem. But even when that's not the case, I think it's another area that would be interesting to do some studies on, particularly how it relates to just our normal social interactions. Like, you get somebody in a leadership position, and they just say that this is how it's done. You get to do it this way, right? And there's a lot of politics that go into that. That's an interesting one. It would be interesting to spend some more time thinking about how that affects things. But I do think that it's sort of incumbent upon people in those senior roles to be the ones that are looking out for this urban sprawl, this code sprawl. They're the ones that should be noticing when things are starting to go that path, and they should be the ones that are thinking about, how do I stop this, or how do I rehabilitate the code? once it starts going down that sprawl. Um, the the book I was mentioning before about sprawl repair talks about a third generation of urban sprawl, and she calls it X-urban. And this is where you start seeing things like gated communities, corporate campuses, like strip malls, things that are only accessible via automobile and are starting to sort of like be walled off now. So I think of this in the ways of like we've got a problem in the code, and we've seen that there's this piece of code over here that is like that's no man's land. Nobody wants to touch that. So we're going to wall it off, and we're not going to touch that anymore. And because we don't want to get in there and touch it, we're going to create this other piece over here, and it's going to be beautiful. Like nobody's going to mess with it. We're just going to create this new little island over here, and it's going to be walled off, and it's going to have gates around it, and it's going to be beautiful, right? Problem is now you start getting concepts that are they're fully cut and paste in some cases. I call that clipboard inheritance. It's too painful to refactor the existing stuff, so you just move the things that you don't want to live in this old crufty area to somewhere new, and it's often sort of as a reaction to the mess, and you start putting strict boundaries and standards that are stood up around this new code, right? And this is where that sort of Dunbar's number kind of goes in here. It's like you start putting restrictive rules and laws on things. It's like gated communities, and where you start seeing master planned neighborhoods with homeowners associations. You start putting that stuff up because you don't even know each other. Like if everybody knew one another and you all had a common set of social mores and stuff like that, you wouldn't need to worry about, is Chris going to mow his lawn? Is he going to paint his house aquamarine or something like that? But at this point, that urban core that we talked about before, it's fully in decline. Like things that used to exist there are now spread everywhere. Usually it's like core services that you start off with, but they start to leak out to other parts of the app. You'll start seeing like logging in different places. You'll see things not necessarily going through your beautifully crafted data access layer. Now you've got pieces over here that maybe they're talking to the database through a different mechanism, or just bypassing it entirely.
Yeah, they just go after the tables.
Yeah,
I've seen it. I've seen it. Where wait, we had this abstraction layer. In fact, we even had a whole service that was designed to be the abstraction layer, so that maybe we don't use a database someday. And then, but this guy over here just went around straight to the tables, and it has this coupling effect, because maybe you became reliant on the system working, but so the original purpose of that abstraction was, we could go work on the database now, and we'll just we'll fix up the abstraction, and everybody who's using the abstract service is going to benefit. But wait, these other areas just went after the tables, so we're coupled now, and no one wants to touch it.
Yeah.
Everyone wants to back away, and I'm talking about intelligent senior developers who maybe even had a hand in creating it. You just want to back away. You get scared to death, and it's just it's strange how that phenomenon starts.
Yeah, it's true, and we mentioned the repository pattern before. This is actually one where I see that happening quite a bit. You start off with this repository, and it's segmented in such a way that makes sense at the time. You have a customer repository, and then you'll have an order repository, and then what happens when you need something from both domains? You want to see customer orders. Well, now where does that belong? Does it belong in the customer repository? Does it belong in the order repository? Do you create a customer order service or something that gets them both and munges them together? And so it starts becoming painful, and then things you start thinking of ways of trying to work around it. And so, like, code that should exist sort of in that urban core that probably should somehow exist in that repository, like it now starts getting crammed somewhere else and into this sort of diminished urban core, because that's the easiest place to put it. maybe I create something that lays on top of these two repositories, but then you start figuring out that it's just not worth it in general because you always end up with a repository needing to talk to another repository, and then you're done. And that's why that pattern I find is a good example of how some of this starts to happen. And so when you're at that point, now you're fully in this like last generation of code sprawl. Now you've got things that are just walled off, and you've got duplication, and you've got there's no soul anymore to the code. What was once there, what was once a clean, beautiful architecture is now totally diluted and incomprehensible to what it used to look like.
So earlier we were talking about dependency injection and IOC containers. Do you think that when you've decided to adopt an IOC container, that unless you're careful, or maybe your thesis is that even if you're careful, that you've now contributed to Sprawl in a way?
Yeah, I do. And this has been an unpopular opinion, but I actually feel like when you start using IOC containers, then you're already well down the path to this sort of code sprawl. And what I found that the pattern to be is it's well intentioned. So here's what happens. And you guys tell me if you've seen this pattern before in the code bases that you've seen or the teams you worked on. You have a team that decides that they want to start doing unit testing, or they want to do better unit testing. Maybe they've heard about things like test-driven development, and they're like, I'm going to try that. So the first thing that happens to a lot of these teams is, number one, they get stuck because they don't know how to begin. And so they'll begin somewhere. And oftentimes it's going to be like this kind of naive learning process. But they very quickly run into roadblocks. One of the first ones is, how do I test a private method? You can't.
Yeah.
You don't. You test it through a public interface. But they don't know how to do that yet. They don't know how to write code like that yet. And they have code that is horribly coupled to other systems and other services, which make it very, very difficult to test anything at all, much less this private method. So first thing you do, make everything public. Okay. Now, all of that stuff that you learned about what object-oriented programming was supposed to be starts coming into question. You don't have encapsulation anymore. Everything is public. And all of these notions that we heard about the pillars of object-oriented programming, they just start to disappear. And inheritance is another one of these things where we've learned over time that maybe inheritance is a bad thing. Encapsulation becomes less valuable now because you want to figure out how to test your code. But test-driven development, I found, which I really actually like, and I think that it's a very powerful teaching tool. It illuminates areas where you need to learn, where you haven't quite figured out how to architect your code or design your code in a specific way. And every single time that you run into a situation where you say, I don't know how to test this, that's a red flag to say you have something to learn. And so what ends up happening, I have found, is so you start saying, okay, I'm going to test this stuff now. It's really difficult because I have dependencies. I have newed up a direct database connection, for example. I don't want to do that in my code. So I've heard about this thing called dependency injection. So now I will inject a database gateway or a repository or something like that. I'll inject that into a constructor somewhere. Great. Now you still have the dependency. It is just exposed. So that's one of the key things. People start thinking, I'm making my code more loosely coupled. But you're not. You're just exposing the dependencies at that point. And then at some point, because you still don't know yet how to design objects, you run into other problems, like you have a lot of dependencies. And so you get to the point where you start injecting 5, 6, 7 dependencies into some object, and now that becomes a pain. How do you get past that? You think, how do I continue to test this? Well, things like mocks come into the picture. Mocking frameworks start easing your pain. They don't remove it, they just make it less painful. And then finally, you're like, how do I wire all this stuff together? Well, there's these cool things called IOC containers, and they have this magic auto resolution. You just have to like register all of your stuff in there. You register all your dependencies, and boom, like magic, they wire themselves up. So once again, you have not made your code less coupled. It's still the same level of coupling as it ever was. It's just hidden now.
You just hired somebody to manage the coupling.
Right. And the problem then becomes, now I have no idea. Like I said before, all roads lead to the DI container. And if you want to go and comprehend the code, good luck. Everything that happens gets newed up in the dependency injection framework or your IOC container. And now it's super hard to get out of. You have to figure out how to go the next step, which is to truly decouple your code, which we could talk about for a long time. But the IOC container, the DI container stuff is, to me, one of the big signs that you've got some pain around your code, and you've got some sprawl there now. Like you have no pattern anymore. There's no defined flow from object A to object B. That when you had the train station before with the specific train tracks that went somewhere, you don't have that anymore. It's a bunch of cars driving everywhere, and you hide that behind interfaces, and it makes it even harder to look at. So that's one of the things that I know that in the projects I've worked on, I've gotten away from that and tried to work with patterns that actually really do decouple things instead of acting like they're being decoupled and placed in an IOC container.
So can you give us some examples of that? Like,
yeah, so
a concrete example of, because I mean, dependency injection, I don't know how you get around it without, but if you want to achieve that loose coupling, you still need something that manages all these relationships and stuff. So not following how you solve the problem.
So would probably be easier to show some examples here, but actually one of the ways that I mentioned before was this idea of a mediator pattern. And so if you think about how you generally see like an MVC controller,
Mm-hmm.
what I'll see is a controller that has some sort of auto resolution of dependencies. It'll inject an I repository or something like that, and that's what you call to get the information that controller needs. And then a bunch of other stuff, iLogger and credit card processor and whatever. You've got this whole grab bag of stuff. But should the controller actually have to care about all that stuff? It just wants an answer. It doesn't need to know that a repository even exists, right? So you're adding to the mental burden in that mental house of cards every time that you're injecting something like that. When I'm looking at a controller, I don't care if there's a credit card gateway involved in processing this order. I just want to know, does this person have a credit card? I want to submit an order. I don't care about what happens. I don't care who answers the call. So with the mediator pattern, you have this mediator in between, and it's basically the concept of an event bus. And you have these queries and you have commands, and all you have to know about is that this mediator is going to do the wire up. Somebody's going to answer the call. I don't care who. I can send a query off, and I can say, I can create a new query that says, credit card exists query, and I can send this off to the mediator, to this bus, and something else is wired up to handle that. It's sort of like a pub sub model, and so I don't have to know who answers the call. I have a very specific, like basically a domain-specific language around those queries or those commands. And I can send it off to the ether, and I will get a response back. And so I don't have to care about any of that. And the great part about it is that in some ways it's similar to the concept of a DI or IOC container, and that you are wiring up dependencies. But in this case, you're wiring up things that are handling a question. So it's similar in concept, but you're wiring handlers up to handle this type of query. So in a way, it becomes a central container similar to a DI container, but it's very different in its execution. So again, think of it like an event bus, and you're just sending queries and commands off. I found that for most of those kinds of things, that's what we're doing. Those are the services that we're wiring up in a dependency injection framework or an IOC container anyways. But it does it in a way that keeps the narrative intact, if that makes sense.
So it sounds like in many ways you're advocating having more strongly typed things, like you said, get credit card or verify credit card, having concrete dependencies on things instead of an abstraction like repository. Where a repository may have 10 different methods to do this, you would now have potentially 10 different, almost sounds like message objects. It almost sounds like you're talking more about a messaging type system,
yeah,
as opposed to classes-oriented systems.
Yeah, and you still have classes. The classes become very cohesive because I have a class that just handles one command. I have a class that handles one query. I don't have a repository that has a whole bunch of methods on it. I have very, very tiny handler things that just deal with this one piece of it. But I think one thing that you mentioned was interesting is it's not. I don't think it's so much about necessarily the concreteness, because one way of decoupling things is by not using objects at all. So, for example, I'm a big fan of functional programming, and in languages like C#, that turns into a func or an action, right?
Mm-hmm.
And so if I know that I need information or that I need to call something to do something on my behalf, again, these sort of commands or queries, what if instead of injecting into my class, instead of giving me a repository that I can go query, how about you just give me a function, and I'm just going to call that thing. I don't care where it came from. I don't care if it's an object. Whatever. It's just a function that is passed into me, and I can call that thing. That lowers the complexity in a lot of ways, and it actually decouples things. It actually really decouples things. Instead of there being a dependency on an object or some object that I have to know about now, I don't care about that. I know that I have a function that I can just call to get the thing, and that function can come from anywhere. So that's another great pattern that I like to use where I can is actually give you the function to call.
And then at that point, classes just exist to host functions and methods.
Yeah.
A little more than that.
Yeah, or to sort of glue things together, and you end up with a bunch of functions that do things.
So to Todd's point, you end up with kind of class explosion, and I don't necessarily mean that negatively. I'm just saying you end up with a whole lot more classes because you end up with what is effectively a class per function, whereas you might have had 10 or 12 functions or methods in a class before in one class in one file. Now you've got 12 classes and potentially 12 files. I know you had the class versus files discussion earlier.
I don't think it cares though, right, Matt? Because let's say I'm an object that needs to do 3 things, and so I'm asking you for 3 functions. Nowhere in that are we saying that they can't come from an instantiated object, a static object, an interface. I don't care how you get it to me. They could be 3 public methods on the same object still, if that makes sense in your concrete implementation.
Sure.
Like you were talking a little bit earlier about, maybe what the controller really wants is the credit card processor and not to know a whole lot of the details. And it's like, well, maybe we even take a step back and say, I really just want the cashier. Because when I go to the store, the cashier can handle lots of forms of payment. He can handle a credit card. I could give him some cash. I might give him a gift card. And so the controller in this case is like, I don't even really care. Just some cashier here, handle this. And so if I am giving you a credit card processor, a function in the credit card processor object, it could be a concrete public method, but all I care about is func that takes a func that I will pass these parameters, maybe how much money or is required for me to accept the transaction, and maybe what the thing is you're buying, and then tell me if it worked. So I get a bool back, and so that's, now I'm totally decoupled. You could give me an object if you want. You could give me an interface.
Yeah, I think that's key. Is like, yeah, there's, well, and the other part I think that you were mentioning before was that maybe you have some class explosion now too, and I think that can be true. But what I would say is, it seems to me that the sort of the concepts, they existed somewhere, and they were probably, all of those concepts were all in one class before.
Right. Sure.
They might all have been in one repository.
Mm-hmm.
And now what you're doing is you're making that explicit, and you are naming those things, and they become their own sort of microcosm, and they can become a very cohesive object, a very cohesive query or query handler or command that you're issuing to the system. And I found that a lot of these things are 20 lines of code. Like it's an object that is 20 or 30 or 50 lines of code, and you can compose them together in novel ways. And then it's all about this composition, idea of composition, instead of having inheritance hierarchies and things like that. So yeah, you end up with a lot more classes in some cases, but they're very clear on what they do.
Yeah, and compose them together in multiple ways, right? Like your example before of, yeah, I use this one to get customers, but I also use it to get the customers when I'm doing the customer order query as well. Yeah, that makes a lot of sense.
The other thing I like about being able to put them together that way, and especially with this idea of doing it with this sort of event bus or a mediator, is that you can wrap things up and chain things together in interesting ways. So, for example, let's say that I want to log the results of these queries that I'm answering, or I want to log how long they take to execute. The naive way to do that is put some timing code in each of these objects. But because you have this middleman, this mediator that is taking an incoming message, finding the person who is supposed to answer it, and then calling that and returning the message back up the chain, you can now do interception in there. So you can say things like, hey, I know that this guy actually is supposed to handle this question, but before I delegate it to him, I'm going to wrap it, I'm going to decorate it with a logger, a timing logger. And now that actual, like your domain code in that little handler is super concise. Like you don't have any logging code to log entry and exit. If you have to bake in security, like maybe only certain people can execute this command, you don't have to put it in that object anymore. You're looking at this really tiny, concise thing that is it removes that cognitive overhead. I don't have to read through a bunch of logging or security. I can remove null checks in a lot of cases, so that now I'm just looking at the actual pure code. So that's to me, that's where things like cohesion really come in, and they really make a huge difference.
So it sounds like in many ways you're advocating, if you think about, you talk about event bus, almost having workflow or orchestrated driven code for your mediators. Before you talked about the idea that I have customer and I have orders, and now I need to have some way to get the orders for a customer. It almost sounds like what you're advocating is this idea I'd have a customer thing to get the customer data, I have something that can get the order data, but then I have this mediator in between that would know how to work with both in order to answer that question. But that mediator would only try to answer that question. It wouldn't try to answer a bunch of other questions.
Well, so in this case, actually, the mediator just acts as a conduit between the question asker and the question answerer, right? And so what becomes interesting there is you don't necessarily think about I have to get a customer, and then I have to go and make a separate call to get a bunch of orders, and there's two separate things that are dealing with that. How about instead I just have something that responds to a query that is, get me all of the orders for this customer.
Mm-hmm.
And now you package that all up in this one thing. And maybe there's some duplication with some other thing that needs to deal with customers. Who cares? It's all this self-contained package. And you can read it from top to bottom. You understand what it's doing. And duplication isn't always bad. In the cases where you can actually like wrap boundaries around things, it's okay if you have some duplication in your code, if, in my opinion, if it makes it so that it is more comprehensible, and it can change at a different rate too. So that's fine. We end up doing ungodly things in the to keep duplication out of the system, and sometimes that damages the design, in my opinion.
Yeah, I think duplication is bad when it absolutely has to be the same everywhere, right? Then you have to be referring to the same implementation, the same logic. Whereas if you kind of do the copy and paste and let it diverge, if they are able to diverge at different timings and for different reasons, then that's perfectly acceptable, right?
Yeah, right. And even you see that behavior sort of exemplified now in the craze around things like microservices. Like, you're actually saying we're just going to create this other little service that does our own stuff, knowing that there might be something else already in the system somewhere that does a lot of the same stuff. But we're going to do it so that we can be agile, we can move, we can change at different paces, right? So I think we're starting to see that it's not always a bad thing.
Yeah, sure. So one of the biggest problems that I've found, especially in larger code bases, is discoverability.
Mm-hmm.
And I've also seen that drive a lot of decisions even earlier on from typically the more senior folks who have said, well, in other systems, they've gotten so large that I never knew where anything was, right? And so that's kind of where I was speaking to earlier about the class explosion. And I in particular don't necessarily have a problem with seeing a lot of classes in a project and kind of finding my way around, as long as there is a pretty logical folder structure in place that kind of helps you get around, right? I mean, it's your map, right? In this metaphor of the city, it's your map of the city,
Mm-hmm.
right?
Yep.
And so, regardless of whether there's multiple functions in a class and multiple classes in the same file, as long as there is some kind of conventional way or some way you can find yourself around, that's fine. But typically, the biggest problem I see is that these systems get so large, there's just so much to keep track of and so much to find and so much to map out that it becomes very difficult. And I find people introducing these, quote, patterns of basically cramming everything together to say, well, you want to know where this is? Anywhere in the system, just go here. And that's I've seen it manifest in several different ways. I've seen it in the God object, right, where you have just one object with maybe a bunch of static methods, and anything you need, you go to this one object, and it points you to all this other stuff. And they all may be their own individual implementations, right? But this one God object ends up pointing to everything. And then I've also seen it where the dependency injection container is the bad guy. You're right. You want anything? Well, just inject it into the constructor. I don't know where it comes from. You get it. And then along those same lines, using the dependency injection framework as the service locator, where you're literally saying,
Mm-hmm.
Service locator dot get me this instance, and that's how I know how to find it. And so all of these things, as far as I'm concerned, goes back to discoverability. So how do you address discoverability in this with the approaches that you take? What kind of patterns do you introduce to address discoverability?
Yeah, I think I think you hit the nail on the head. Discoverability and just comprehensibility of what's going on in general are they're paramount, right? And when you use those patterns with a IOC container, for example, I think one of the things that you said there is like, hey, we don't we don't know where this goes, so let's just inject it, and we'll utilize it. That to me is the area where this pattern, specifically with using IOC containers for everything, is so insidious, is that it hides the pain so well that
Yeah.
you haven't solved any problems. You've actually exposed problems and maybe made them worse, maybe made your cohesion worse, just because you're not feeling the pain so much.
Yep.
And one of my favorite sayings, actually this came from my other side job, not really side job, but other area of interest around continuous delivery and DevOps and stuff. The guy, Jez Humble, who literally wrote the book on continuous delivery, one of the things he says in his book is, I'm paraphrasing, but he basically says, if something is painful, do it more often. Don't do it less often. Don't figure out ways of not feeling the pain. Feel the pain. Live it. Do it more often, because you're going to get tired of it, and you're going to engineer your way out of it. And so I say rip the Band-Aid off with the IOC containers and actually look at the real patterns and ways to truly decouple code and not pretend that you're decoupling code. And the thing that's challenging about that is that in order to do that, it pretty much spans the entire corpus of design knowledge that we have right now in software. It's not a quick fix. It's actually pretty hard. It's there's a lot of books and knowledge and even patterns and things like that that can come together to really help you fully decouple things. We talked a little bit about a couple of these. Having sort of an event-driven system can be one way. Using more functional concepts can actually increase the cohesion a bit in your and basically in your code, because you're not caring about where these things come from, and you're lowering the amount of cognitive overhead that you need. And so it doesn't matter if this function is being provided by some particular class or another. You can swap it out at any time. You don't even care about class level cohesion anymore or coupling, because it comes from a function that is being passed in.
Yep.
So these are the things where it's now more about how do you really decouple things. So things like a mediator pattern, which is basically an eventing system, can help. Things like separating your commands and queries, and looking into some of the patterns that Greg Young and folks have made more popular around CQRS. Things of that nature, where you're actually looking at, let's really decouple things. Let's stop pretending. Those are the ones that have been most influential to me.
So now, how do you apply this in the real world? Because
Totally.
I'm not accusing you of not living in the real world. What I'm saying is you are clearly very smart, and I would love to have you on my team, but you are not scalable, right? Not everybody has access to you, and not everybody has access to architects and folks that are very aware of these things and understanding and know how to break these things down, right? So, for example, as you're talking about dependency injection containers and talking about trying to get away from them, and they're not really solving the problem, they're just kind of pretending to solve the problem. All of your examples, everything that you're saying, I completely agree with. But to hear you say, let's just ditch the dependency injection container, I think going away from what I see a lot of folks using now, which is just these single classes with 2 or 3 methods in them and 500 lines apiece in the method, right? Going from that to a dependency injection framework, that's always a step in the right direction, right? It may not be solving the problem, but at least it's helping them organize the code a little bit better and at least split things up and get a little more, solid.
Well, it's like, how do we skill up the team, right? Because I mean, we talk about this a lot. Is okay, now we want to take this to work. And you can't be the only one trying to break dependencies, trying to use patterns. How do we, especially if you run a large team, it's how do you make your, the resources available that they're there's, how do you
Right.
get everyone to
Well,
think this way?
even if we're talking about a greenfield project,
Yeah.
right? So how do you take folks on a greenfield project? So we're talking about completely new,
And
not
prevent
how do we
sprawl.
change the existing code base? And yeah, from here, we're all developers who are used to dumping tons of business logic in a click handler. How do we, from scratch, we've got the world at our fingertips here. How do we go from there to implementing these patterns? What do we do?
Yeah, so these are great questions. They're the hard ones actually, and I should clarify. Let's not ditch the DI container. Let's not ditch IOC containers. Let's just not stop there. Remember what life was like
Yeah.
before all of this stuff? That was the way that you did it, and we've learned some better ways of at least now your dependencies are exposed. Before they were just hidden, right?
Yes, right, exactly.
So at least now they're exposed, and
Yep.
and hopefully you can look at the method signatures or the class prototypes and learn something about what they're doing. You know that you have to inject these certain things, so it must be doing something with the credit card processor, because else why would it require it, right?
Right.
Challenge
Yeah, I
there
mean,
is
to
that
say that they're not decoupled, they are certainly less coupled than they were when they were all in the same method, right?
they,
So to take those 20 lines of credit card processing code that would happen to be right after the 20 lines of getting the information from the customer and putting them in different classes and then
Right.
wiring them back up,
Yeah.
that is certainly more
Right.
decoupled, right?
Just
Well,
the
it
fact that
is.
you
It
didn't
is.
new it up. You've done a little bit less coupling.
Yeah, I think the interesting thing there is that there are different levels of coupling. We don't think about them that often, but if you look at the different sides of the spectrum, at one end, it's you knew something up. You have code level coupling. Even within your object and your class, you have coupling at the code level. Um, that's one. That's probably the. I think that's the most coupling you can have. It's all in one class. You're newing everything up directly. And if you look like on the other side of the code, it's like machine code. It's like byte code that you don't even have any structure to the code at all, but it's all just message passing. But you can get less and less coupling. So you mentioned when I start injecting things, that is now a lower level of coupling. When you start talking about now not caring about the actual object that you're introducing, and it's just a function now, that's even a lower level of coupling, because
Sure.
now you're not even coupling objects anymore. You're coupling concepts, more about concepts. And I don't know what's the next level down there, but there is something interesting there. But back on your question about like how do you do this in the real world? There's one thing that I think that might bear some thought and investigation is not surprisingly some things that have parallels in the real world. So there's a notion in architecture and just building planning and stuff like that of defensive architecture. And it goes by a couple of different names, but this is basically when you go out and you see those little metal studs on concrete blocks to keep people from skating, doing
Yeah.
rail grinds and things like that.
Yeah.
But it's even more insidious in some ways. It's park benches that have partitions in between, armrests in the middle of them, so that you can't lay on them, right? They don't want it's to keep homeless people essentially from sleeping on these park benches, and that kind of stuff is pervasive and almost invisible in a way. But I wonder if there's something like that we could do in our architectures and our designs. As more senior folks that are starting off a project, hopefully it's greenfield, maybe it's not, are there ways that we can create architectures that are defensive, that don't allow you to make mistakes, or make them super obvious when you do make them, or when you're straying from an established pattern? And that is one of the areas that I think that we have. There's some work to be done there. And you mentioned before just discoverability. like that's one of those ways where if you can show, if it's easy to understand where something is, that helps out a lot. But with some of the stuff I was talking about with this, for example, this mediator pattern, it's hard. It's much harder to stray from that pattern because you actually have to do anything in the system. You actually have to create a class that asks a question, and you create a handler that answers the question. If you are just, if you're not just completely oblivious, you can see that that is the pattern that is in your system. And because of that, the way that it's set up is it's very hard to start making objects that do too much. There's an insulation factor to it, because you can't make it terrible. It's harder to make it terrible because it just doesn't work that well when you stuff a bunch of things into one object, one handler to like you're not going to ever have a handler that handles 15 different things because nobody's ever asking 15 questions at once, right? So those are some of the areas.
I've seen people who can do it.
Yeah, it wouldn't surprise me. There's a guy, I forget the name. There's a fairly famous book called The Design of Everyday Things, and this is where the idea of affordances came from. And affordances are, we use them wrong, but the idea is that the affordance is basically the behavior that something that you can use on something. Like if there's a coffee cup with a handle, I can interact with it by holding the handle. And we've taken it to basically mean that the handle is the affordance, but it's really about the behavior. Anyways, what if we can make affordances in our code, like make it abundantly clear what the structure of the code is and like the way that it's intended to be interacted with. So like clear naming is one thing. And we mentioned things like directory structure that we can use to like communicate the design of the application without even opening the code. Some of the other things, the mediator pattern we just mentioned, put the commands and queries in separate folders. It defines the high-level messages that are in the system and what are being passed around, and it sort of describes the core functionality of the system without even opening your text editor. So it's kind of like an affordance in that way. Another interesting way that I've seen that I've put to use is, are you guys familiar with Conway's Law?
Yeah, it's
so
about
Conway's,
organizations, right?
Yeah. Conway's Law basically says that organizations that design anything, they're constrained to produce designs which are copies of the communication structures inside of the organization. So the idea is that if you have these super siloed teams that don't talk to one another, they're going to build super siloed code that doesn't talk to each other very well. And this has been shown over and over again.
That sounds like the real world everywhere.
It is. And it's funny because you can actually see somebody's created a few pictures of Conway's Law, and it'll show things like Facebook, where the way that they're structured is there is no structure. It's a graph. Like, it's anybody talks to anybody. And what came out of that? This graph structure, this social graph structure that is so prevalent. You look at something like, I don't know, Apple. It's a circle with Steve Jobs in the middle, and everybody talking to Steve Jobs, right? So it's really powerful, and where I find it's powerful is not just in its sort of like ha-ha factor, it's that you can actually put Conway's Law to work for you. And let's say that you want to create sections of your code that are walled off and don't have sprawl. I've taken teams and I've split off subteams from them and actually put them in a different part of a building and had them live there while they created that piece of code. And it turned out to be walled off and didn't talk to the other code very well. So you can be pretty creative. And if there's areas in the architecture where you don't want there to be sprawl, you don't want there to be sort of rot of your cohesion, think about how you can actually move members of the team somewhere else. This may be hard in some organizations, but think about if you can't move where you are, maybe change your communication structures. Maybe I don't know, this is crazy. Maybe you don't have everybody go into the same stand-up if you're doing Scrum. Maybe you actually have two separate sort of sub-teams that deal with this stuff. You can do
I'm
this.
dying to ask how offshore teams affect all this, but that's a whole nother show.
Yeah, yeah, that's a fascinating one, for sure. And I think that again, they're affected by Conway's Law. They play right into it as well. So I haven't ever found, unless you are in very close contact with offshore folks all the time, that they're ever able to be that tightly. You don't end up with a lot of cohesion amongst the team itself. So
Yep.
that would be an interesting one to take a look at. There was one other thing. I know we're going on for a while here, but there was one thing I found fascinating to think about. A few years ago, I don't know, it's probably about 10 years ago, the government was trying to figure out how to solve the problem of nuclear waste containment, and specifically, how do we communicate to future human beings that this is not a place that you want to be messing around? And they were looking at 10,000 years, because that's how long this particular nuclear waste would take to become not harmful anymore. So if you start thinking about how do you communicate to people that might not even speak English in 10,000 years, that might not even have the same idioms. Like for us, what do we think of for poison? The skull and crossbones. Well, that hasn't always been the thing, and it might not be even something that you would even be able to comprehend or make any sense out of in 1,000 or 10,000 years. And so they came up with some really fascinating designs about how they would communicate to basically aliens in the future about this is a bad place to be. Don't come here. Don't dig here. This is not a place of happiness or worship or value. This is a place that we do not value. And walled things off in a way. And they did it with things like earthworks. Like they would create these, this is out in the desert, they would create these gigantic looming like walls that are black, and because they're out in the desert, they're just hot, like they bake down on you and they make you physically uncomfortable to be there. They had this idea of like a field of thorns. So think about like a thorn bush, but with these thorns like sticking up out of the ground, 40 feet tall, made out of concrete. They just look menacing, right? They don't look like it's uncomfortable for you to be there. And so I think that there is something that we could do there. I think there's things that we can do to put those kinds of affordances into the system and make it crystal clear about this is where the code belongs. This is the thing that you're about to add. It doesn't belong here, or maybe it does. Clearly, if you're dealing with something like this mediator where you have handlers that handle a very specific question, there's a lot of stuff that doesn't belong in there. And it's super clear. It's crystal clear. Don't put that here. It doesn't make sense. So
They even talk about redundancy and defense in depth, to warn people again and again. This is so fascinating.
Well, and so do you have any kind of examples, or do you think, are there going to be any kind of universal ways to do that, or is it going to depend on the project, or both? What are your thoughts on that?
honestly, I think that we're not good enough yet. I think in this industry it's still so immature, and things are moving so fast that even the constructs that I talk about here, they pertain to object-oriented programming as we know it today, and that's not even in vogue in a lot of places anymore. So the things that we talk about there just are not going to be the same problems in a functional language, for example. They solve these problems in very different ways. But I think that we talk about code quality a lot in this industry, and I've sort of come to the conclusion that maybe code quality is not it's not the important thing. Like, I don't mean to say that it's not important, but we don't even know what it is. We don't know what good quality code is. Like I was saying at the beginning, your code sucks because it's not how I would solve it. There's not a lot of measurements.
Well, because you don't understand it, which is
Yeah,
inherently subjective.
maybe you solved it in a way that seems wrong to me, but we don't have any objective measurements or qualitative measurements that tell me if my code is good or not. We can look at certain things like performance. We can look at cyclomatic complexity. We can look at cohesion and coupling in a lot of different ways, and we can sort of start to triangulate whether or not a piece of code is good. But we don't. You take two people and ask them what code quality means, and it's going to be all over the map. So that's one of the things that's really challenging about any of this is that we don't agree on anything in this industry. We don't agree upon what is good. We don't agree upon what patterns are good or bad. And so that makes it difficult, especially when you get out into the real world, back to your teams, to try to convince anybody that these things are good ways to go. I don't know. I don't know what the answer is. I think that we just have to keep at it. I think we have to be having these conversations. I think we have to be asking the questions as we look at code. I like to just look at, like, back to the kind of code sprawl thing is like, it used to be that you could walk to the grocery store, right? Can't do that in most places anymore. I like to think of things like, how walkable is your code? How many steps do you have to take to get from the message coming in to the message being responded to or received? If it's 15 different objects, if it's a whole bunch of layers of indirection and abstraction, if it's you have something coming in from one side, it's coming in from a form and it's being mapped into a model, and then the model gets passed to your whatever object that deals with it, and then it's mapping it to a DTO so that it can send it to your repository, and then something goes into the database, and then it comes back the other way, and you map it back, and it goes. This is nonsense. This is crazy. Like, the code isn't walkable at all. It becomes very difficult to even reason about it, and you end up with just a whole bunch of ceremony to do even the simplest things. And so I think we just have to be talking about how we make things simple, how we can isolate things. And that's the thing that's fascinating to me about this talk about urban sprawl is we have physical analogs to this stuff that we can draw upon. And analogy is such a fundamental cognitive tool that we use in our brains, and I find that can be a very powerful way to start telling these stories. And I think that's, to wrap it up, for me, that's what I think is sort of interesting about talking about code sprawl and sort of comparing it to what we see in the real world.
I love
Awesome.
that. How walkable is your code? That's awesome.
Yeah, that's perfect. So Matt, did you have anything else? Or we wrap it up there? That sounds like an awesome place to wrap it up.
That's great. I mean,
I have plenty more questions, but we're already in 125, so.
Yeah, we'll have more shows, man.
Yeah, definitely.
Yeah, that'd be
There's
great.
a lot of topics that just came out of this.
Yes.
Yes.
All right, cool.
Yeah,
So,
that's the thing that's so fascinating about this is we could talk about it at length, in many different, probably a lot of different shows. So I'd be happy to come back and chat about any of this stuff, or if you have any thoughts in the future, let me know.
yeah, awesome. So that sounds like a show. And you, listener, what do you think? How walkable is your code? Have you ever used any of these techniques on your code bases, or are you interested in trying them out now? We'd love to know. Please leave a comment on the website, staticvoidpodcast.com, or send an email to comments@staticvoidpodcast.com. And as always, if you have a topic you'd like us to discuss on the show, please feel free to let us know through those same channels. We want to make sure that we're talking about the things that you want to hear about. So, Matt, thanks for joining us.
Yeah, that was awesome.
Yeah, thanks a lot.
Great.
Appreciate it.
Chris, Todd, thank you as usual.
Cool.
And thank you, listener, for spending the time with us. We hope that you enjoyed it, and we look forward to seeing you next time on the Static Void Podcast. That's it. That's a show. That was freaking awesome.
Don't let us down, Zencaster.
Yeah, right.
Yeah.
That
Okay,
was
Matt, that was
so
just a
awesome.
try. That was just a trial. Let's do it
Okay.
again for
Yeah,
real.
you
now.
have to come back and do all of that.
That was
That was the practice run.
Oh, I hope you were all recording. No?
I thought about it. I was like, that backup.
yeah.
Well, I mean, I was recording on my task cam, but that was just to try this thing out.
Yeah.
Figured it was an
So
awesome
that
test run.
was a very good discussion.
Oh, good.
Certainly made me think through some things I'm dealing with on a day-to-day basis today. It's like, I could some of these patterns may actually help me break some of the way you described of you call this to call this to call this to call this. I'm like, that's my pain point right now.
Yep.
Yeah, and it's not abnormal. I mean, that's a
Yeah.
pattern du jour
This
over
is
the
some
last
code I
few
inherited
years.
too, and it's just like, why am I constantly going back to cache to get things every time I call something?
Yeah.
Just get
No,
it and
it
use it.
resonated very, very much with me too, because I felt the pain of dependency injection and IOC containers and everything, and I've also felt when you have these. I had very message-oriented systems, and the team never really bought into it, and so it never really went very far. But it worked, and it was a pleasure to work with. But you ended up with a lot of message handlers, and so that became very difficult to manage. And I think really the answer there is not a different design pattern. It's just find a better way to organize and manage these things, so it's more kind of understandable.
Yeah, I think that's the challenge with where we've gotten with things like dependency injection and IOC. They're good, valuable steps, but
Yeah.
we don't have. There's no guidance to say what now. Like,
Yep.
how do we get to the next step? Because you don't want to stop there.
Yeah.
That's where there's still pain, but we don't have any advice yet to talk about this stuff.
And it's infuriating when you're saying, where is this logic happening and how did I get here? I got from here and I ended up over here, but in the middle was this big cloud of stuff that I have no idea what happened.
I
that's
thought two
what-
things
yeah.
during our conversation. One was the idea that we talked about the map is dependency injection GPS. It's how we find stuff now. The other thing was when you were describing I created dependency injection now, I'm using it, is how many of us have took a repository and created an iRepository for customer that has the same 10 methods. And all of a sudden now, I'm not really dealing with a different abstraction. I'm still using the same abstraction, I'm just telling somebody else to be the traffic cop that created it. So.
Yeah, and it's get by ID.
Yes.
Yeah.
Right.
Yeah.
There definitely is
I know I was in a project that probably was so over reliant on dependency injection, and I think the clue was that file, that root file that was setting up the dependency injection was always open in Visual Studio.
Yep.
That roadmap was always open. So that was probably a clue, right? That we're passing so many dependencies into things that maybe don't really care about the individual dependencies. I've got to have the roadmap.
Yeah, and actually that's the thing that's interesting is we've gotten to this point where the new operator is evil, right? And when it shouldn't be evil, you should be able to new things up in the right place. That's where I like the idea of having very discrete handlers for things, because you can new up your database objects and stuff right inside of there if you need to, and it becomes super easy to mock those handlers if you really want to do that and not hit the database at all.
Yeah.
Because they're just behind some interface.
What's evil is the knowledge required to new something up. If everybody needs to know all of if everybody needs to know the database connection string, the fact that it is a database connection and the database connection string, then now whenever you have to change that, you're changing it in 300 places.
Right. Yeah. Oh,
Yeah, I'm super fascinated by things like bind, because we talked about it just a little bit, where in a functional context where you say, I mean, we've talked about this on the show where we talked about null, we talked about defensive programming, and so you have some method that's going to do some work, and in essence, all it's really going to do is make a decision and then call one thing or the other thing. It should really be 6 lines of code, but after you do your defending against null, your try catches, your iDisposable handling, it's 33 lines of code, and so one way around it is using functional constructs, whether it's in C# or F# or something. And we don't even have to be in a .NET language. You could be in JavaScript, and you use bind. Well, then here's what worries me, right? I love it. I love how the code looks. I love how whether I add a logger, the business logic's the same. Whether I add a timer, the business logic's the same. But now I bring a new developer on the project, and they're going to open the thing, and they're going to go, well, how does the logging even happen? and the brain lock will begin. And how do you bring that to your team without confusing the crap out of them or burning you at the stake as a heretic?
Yeah.
Because that can happen too. They're like, "What are you doing? This is so complicated."
Well, at one point in time, dependency injection was like that. So it's all evolution.
What's old is new again.
I'm still quite convinced all the programming in the future will be done in Minecraft, so it don't matter. You move a block from here to there, wire it up, and magic will happen.
Hey man, I did one of those things where I created like an 8-bit arithmetic logic unit using redstone in there. That was awesome.
It's a higher level contract, man.
So what is going on in your Zencaster windows right now?
I think we're just talking, right?
Because all of yours say recording in progress.
That's what mine says too. So does
Do you
yours.
need to stop it?
So
Do you have
mine doesn't.
controls at all? Maybe you're just like saving and uploading.
All I see is my own. I only see my own name, but it says recording in progress.
Oh,
see
actually,
it
you're
for
right. It does say recording in progress. Yeah.
Mine
Oh,
says
God.
all audio uploaded. Okay. All right.
It probably takes a while.
God.
I get.
Oh no.
I'm gonna raise my hand. I raised my hand. That's
That's
what I can do.
So Matt, are you free for the next hour and a half? Because we're all going to turn on Audacity.
Free for like the next 8 weeks.
Let me try this. Hold on. I want to see if I can screen share something.
Matt, I think you just brought our show to like the next level. We've been talking about nulls and exceptions.
Oh, dude. I love nulls. I use them as much as I possibly can. Let me see here.
Hey, we talked for an hour and 10 minutes on null.
Yeah.
I like to get into what, like, null, like the Zen philosophy behind null. That's my favorite.
Yeah.
Let's see. See if I
So
can
Jeff,
share.
you stopped Zenmaster, right?
I stopped it a while ago, yeah.
So at some point this may pop up with, here's your recording.
Yes. I think the reason it was so quick before is just because we were doing like one or
Oh,
two
we're doing like a minute and a half.
8-minute recordings. Yeah.
95 minutes.
Yeah. Stop laughing, Chris. Everything is going to be fine.
Chris is like, this is going to be fun to edit. Chris, look at it this way. You, Matt, and I will be fine. For some reason or other, Jess will be like 3 seconds behind all the
No,
whole
I
way.
have
Yes,
my,
yeah, right.
my Tascam recorder
Just start
now.
stomping all
Everything
over
is gonna be
people as
great.
usual. I love that. When I was listening through the WCF episode, right?
Yeah, no, that's a great idea.
So here, Chris, why don't you tell us a little bit about Web API? So Web API is, when you use Web API, you've really made a commitment to HTTP. And so what that means, and just like, well, that sounds really great. Let's move on to something. And I'm like,
Hey, is this showing my screen at all?
Yeah.
yeah.
Yes.
Okay. There's the visualization
Yeah,
of the
yeah.
sprawl. Like
That's
the black.
exactly what I was picturing as you were describing it.
Oh, good. Well, the stuff in the upper right-hand corner is just the black stuff. That's your urban core, and then you'll see around, the streetcar lines where things kind of start to build up, and you'll see some of those little black dots where it's like you have a couple of little things that are starting to move out from the core, but then it's like you get into this one, and you can see this sort of like beige ring that's starting to build out. Those are highways and interchanges, and you can see a lot more of those black dots. They're no longer in the urban core. They've spread out.
Mm-hmm.
They started to spread out. And then this is like this third generation where that beige ring is now way far out, and there's almost none of the urban core left in there. It's all just spread out all over the place. So those are the things where you can make a lot of analogies in code to what that
And, like,
ends up looking like.
Totally
Your
like
whole analogy with the strip malls, I think, was the thing that made a lot of sense.
Yeah, because like where we grew up is totally like that too. Because you know how you might even remember, Matt, like when we were really young, the 57 freeway was. I mean, it was probably important to us living in La Habra, right?
Mhm.
But then when we go back home now, I've noticed that every off ramp on that freeway is now adjacent to a strip mall. And I don't remember it being that way growing up. It was almost like, well, this is the greatest place to put a commercial shopping center because you're getting off at Lambert, getting off at Imperial, getting off at Orangethorpe, like every single freaking one, even if the exits are a mile apart.
Yeah.
I tell people in Southern California that there are places where I can drive literally a mile and a half and pass 4 targets because they're Beach and Imperial's a good
Levittown.
spot. Well, I mean, I know that's out here too, right? I mean, but it's just, and how it's so weird how you built the freeway to get people from, say, Santa Ana up to Pomona, but then you put stops along the way, and so that's where communities formed.
Mm-hmm.
Yeah, that's it. And I sometimes joke with folks that live still down in Southern California, but like you don't have to ever leave. There's no place that you ever have to go because everything that you need is in one place. But
Yeah.
there's really there's no neighborhoods with any sort of like character or anything like that.
I thought it was interesting how you said it didn't have any soul.
Yeah, it's soulless, and you
So
can
they try the faux soul, like those neighborhoods they're building now, like downtown Brea. It's like pretend we're gonna force it.
Yeah, but actually, I think that's what's interesting about that one is that is an attempt. That's an attempt to repair urban sprawl, and there's that the book I mentioned a bunch of times. It's actually all about that. It talks about what it looks like, but it also talks about how you start repairing it at the city level, even at the building or like neighborhood level too. So I actually like that they're doing that stuff. But every one of us has probably seen code, probably more often than we'd like to admit, that is soulless and without shape, right?
Yeah. I see it every now and then, I guess.
I think we've probably all written some in the last few weeks.
Oh yeah, we probably all.
Yes, that's true. I've contributed to it. What are you talking about?
Yeah, it just naturally evolves that way. It sort of sprawls out over time.
Yeah, well, and then there's the code. Then there's the code that is just like a pleasure to use. Like as you're contributing, you're actually it's a pleasure. I mean, it feels good.
Yeah, those are rare.
Yeah. And they're usually the beginning of projects. That's before the
It's a
sprawl
happy day
happens.
scenario until they introduce the second requirement. It looks perfect.
Yeah, you can contribute to left pad. It'll be 12 lines of code instead of 11. Well, do you guys have to work in the morning?
Yes.
Yeah.
Yeah.
Oh man.
It just takes a lot. It just, like, we're supposed to start at 10, but that usually means 10:30, and then we usually talk till 11, and then we might start. And then the show ends, and then there's the post show, and then at some point one of us will say, "Hey, let's turn off the live."
Yeah.
And then talk
I'll
for
start
another
speaking
45
in half
minutes.
sentences and be like, can you just turn it off?
Nice.
But
Yeah,
no,
we
thanks
pretty
for
much
being here. I mean, I feel like
Normal
I wonder if you belong on .NET Rocks now, talking about Code Sprawl.
Yeah, I don't know. It would be fun to talk about. I hope I didn't babble too much and ramble on about stuff, but it's just such an interesting field that I haven't heard anybody talking about this yet. So
Yeah. Well, it's just interesting. This is yet another. I mean, I'm oversimplifying, but it's yet another drive for CQRS and these other kind of patterns that really just separate things out into it's the culmination of a whole bunch of stuff. It's domain-driven design and the evolution of object orientation or the breakdown of object orientation, whatever you want to call it, but. Yeah, kind of. I've been doing a lot at work. We've been using the flux pattern for our front end stuff, right?
Yeah, React and all that.
Yeah, React unidirectional data flow, and it's amazing. But a lot of the developers just can't grasp it. Right. Even if you sit down and you explain to them, this is the reasoning behind it, and this is why we're doing it, and here's an example of it, and here are the 3 pieces that you put together and everything. They get all of that, but to then sit down and say, okay, I've got a new requirement, and I'm going to do this like fresh. Okay, maybe I have a template and I create these 3 things, but then like, what do I put in them? And it's like the devil's in the details, and even if you get that high level architecture correct. Through things like a template or whatever, it's still, it's up to the low-level stuff that just kind of misses the mark.
Yeah, it is. The thing that came to mind when you said that, and it was when we went back to like, how do you make this work in the real world? How do you get this to happen when you've got a bunch of people that are not knowledgeable about a lot of this stuff? I think that the hardest thing is that like software is the easy part. The people part is really that's the hard thing. and people are so different, and it's a challenge in and of itself. It almost comes down to that you have to have somebody that's charismatic or in some way influential on the team. We rebuilt the last year I spent rebuilding a major part of the Nordstrom website, and we did it with React, Flux, lot of front end stuff.
Yeah.
And that site gets a lot of traffic, and and it's not the most traffic in the world as far as sites go, but when you put it together with the amount of traffic that it gets, which is millions of hits a day, with the amount of front end UX complexity, it's pretty unique. Like you even look at Amazon, who gets way more traffic. Their UX is very simple, and maybe that's good, and it suits them. But it's not. There's not a lot going on there.
Yeah.
And so they bundle a lot of their stuff together. You won't see any third-party dependencies on their pages. They combine it all together. They do a lot of interesting stuff there. But we had to have one or two people that really just drove it. Like they understood Flux and React and all of the technologies, and they were the architect, and they were a senior person that just brought everybody along. And there's something to say about likability of a person, and the ability to persuade or influence is so hard.
Influence is the right word.
Yeah.
It's about influence. Persuade is a negative word. Influence is the positive one.
Yeah.
Yeah. Well, that was the other question that I didn't ask during the show. But it's like because we talked about how do you build it up from the beginning, but then the other side of that is what happens when it's almost by definition good developers, good leads, good architects, whatever. Almost by definition, they're moving on, right? They're moving on to, at the very least, the next project in the same company, but usually other companies, right? That's kind of how it's part of their personality, right? They got to stay on and they got to do,
Yeah, I mean that's what I did. I led this team for a year. We got this new architecture modernization up and running, and it was amazing. And I've moved on and I'm working on other parts, other big.
So then, how is it doing now, right? So when those tech leads, that lead or those leads who came up with this and put it all into place and shepherded it for even a year or whatever. Let's say the thing is done, what then? How do you? Because the reason I didn't ask is I think you already answered it in different ways. Things like setting up these affordances and things like that. But I see that's when projects really start to devolve as well too. Is when the original passionate influencer moves on.
Or you have new people who weren't even involved at all, and they're told, "Here, go get this done," and they're like, "Well, I know how to do it, and I don't know how to do this, so I'm just gonna go off and do my little own."
It's the quickest way to get it done, right?
Well, maybe we don't. Maybe there isn't a way to keep it from rotting. I know that I forget what he calls it. Martin Fowler talked about this recently, where it's not a self-destructing architecture, but it's one that has a built-in timeline to where when it's done, you say this architecture and design, this app will be in place until January of 2016, and then it's done. You build in the obsolescence, and that you're going to redo it at that point.
Yeah, but you can't really do that when you're talking about real cities, though, right? When we go back to what we're basing the metaphor on, you've got urban planning, you got planning committees, right?
Yeah, but if you think about it, there's parts of cities that are being reborn all the time.
Yeah.
So you start over in certain parts of the city, and if you do it carefully, then
But it's always doing it in place. There's no concept of scrap it and start over. V2. Toronto V2.
Resharper for refactoring cities? Is that a Simpson upgrade?
Unless you're Disney, then you can create your own city.
Yes.
Yeah.
So I have a question for you, Matt. Have you ever heard of Metropolis?
The game Metropolis?
No, not the game. There was something Microsoft had talked a lot about when Subway first came about. A guy named Pat Howard created it. He wrote this big white paper. It was similar to a lot of what you're talking about, but it was more about how to solve the problem, sort of. I'll put the link in the chat here.
Cool.
Because when Chris first mentioned this, this is what came to mind. And his concept was, again, this is sort of when SOA and XML sort of was the predominant thing. His concept was IT should model itself after cities. So you should have infrastructure. And infrastructure does, like fire and police, they do certain things. As opposed to all these silos and types of things.
Oh,
I don't know, this might be interesting. It's I mean, it's all 12 years old at this point, but
yeah.
it may give you a different sort of perspective.
Yeah, that is really interesting. I'll take a look at it.
Also big on the whole idea of software factories, which
Mhm.
unfortunately was something that sort of died away. And the idea of a software factory was you have a group of people, it may not even be in you internally, maybe a vendor, and they master how to do X, shopping carts, for example. And they're the thing you use to do shopping carts, instead of trying to everybody build everything from scratch. So, I don't know, it might be something, I'd be curious to see how it relates to it.
Yeah,
Stuff you were reading.
I'll take a look. Thanks for sharing that. I think it's also, I've thought about how you apply some of these concepts to a business itself.
Mm-hmm.
Like, we think about object-oriented programming and things like encapsulation and stuff, and that's all about, cognitive overhead. If you think about object-oriented programming, it's an attempt to make it so that we can relate to code and understand it better. The machine doesn't care, right? It's all about us being able to map real-world concepts into code so we won't screw it up too badly. Right?
Well, it's back to your idea of we can only focus on one thing, right? If you had a class of code that has, I don't know, 30 lines, it's easy to read, but if it's one big function with 4,000 lines, it's very hard to understand everything that's
Well,
going
I
on.
have a concept of what a cash register is and what a bank is and, that kind of thing. So if I could theoretically perfectly model that in code, then that would be great. It helps me to reason about the code. But what if we took similar approaches into how we actually structure organizations? We don't do a good job at encapsulating stuff a lot of times.
Yep.
You have to know who to talk to. You
Yeah,
have to
well,
find
and
somebody.
I work at a giant bank, and discoverability is my my biggest pain point just in my day-to-day job.
Yeah.
Just discovering what are the utilities within the organization, who do I go for for X, and the only way to be successful in the environment is I find myself, even now, I've been there almost 3 years, and I say, who owns this?
Yep.
Who is the person that I go and I talk to talk about this, right?
And
it's
they say,
all
oh, it's in,
ask the guy next to me, because there's no like directory online.
oh, but maybe there is, and it's
Well,
called
there have been
SharePoint.
attempts, and then they're never kept up, and they're never correct. Because then there's like, there's the owner of record, and then there's like, no, this is really the guy who does it, right?
Yeah. The directory is SharePoint.
Yeah.
And then,
Yes.
SharePoint.
Yes.
Go
Then there's
search for it in
SharePoint.
SharePoint.
Well, I mean, or it's email.
Yeah.
Like you've been
The
told to
ultimate
put it all in SharePoint or Jive, but the reality is you've got to email somebody who will email someone else and say, wait a second, I think I have an email from 2012 that
And let me
talks
forward
about
you a
this.
copy of this document. It may or may not be the right document, but it's at some point in time was.
The oral tradition drives me crazy.
Yeah. Hold on. So, do all of you have access to this solo track in Zencaster?
No,
No, we don't have anything yet.
So, in your screen, you don't see solo tracks?
no.
Not yet.
Let me see. Let me see.
All I see is all of us are still in progress recording.
Right.
Yeah, I
can
just see
raise a
me.
hand.
I still only see me.
Did you get them all, Jess?
No.
No, you didn't.
What if I...
I wonder if it's still generating it.
Well, I do know I was looking in Task Manager, and definitely Google Chrome is going off.
Now I see Jess in there. But his says ready. Mine says recording. Oh, no, it shows that you're uploading an MP3.
Okay, yeah, refresh.
Oh, God.
Okay.
Trust me.
It says my upload hasn't completed.
Okay, good. All right, then you're good. Let yours go.
So
Wait,
don't read.
Don't
Wait.
refresh.
wait a second.
Nope, I have unaffiliated track,
Says you're ready to go.
but it says solo track is
Unfinalized?
unfinalized track.
Yeah, click the big red button.
Okay. Finalized. Oh, now it's 1%, 2%.
Wait, so I actually do need to refresh?
Yeah.
That's what I did.
Oh, God.
Yeah,
Your
'cause Chris,
uploads
you're not
haven't
here right now.
completed.
This is the
You will
web.
have to return and retry the uploads later. Do you still want to leave? Are you sure you want to reload this page?
Oh,
I
does it show yours uploading? Do you have like a status of uploading? That's what Matt said.
I
Mine's
do
still
not have a status of uploading, but
Todd and Jess. It says uploading MP3. For me, it still says recording in progress.
Try refreshing, Matt.
Oh man, I'm gonna lose it all. I know it.
It's the web. It's going to be fine.
So Todd, the next show is web as a platform development.
Yeah, exactly. How the browser application.
Browser as a development.
HTTP is the root of all evil.
I see stuff.
Stateless.
Do I
We
do I
had
click
true
finalize
state
now?
and a true
Yeah,
application to record.
this
that we
is
can
what mine
download
looks
from
like.
the
Oh,
internet.
no, I guess we can't.
No, don't worry about it. So I was just reading. They say the way that it works is you have your local recording. Oh God, that means mine's gonna be screwed up.
Yes, it is. You're going to be 3 seconds behind.
So wait, you have your local recording.
There's a local. So it's recording on the server, and there's also a local recording. And so I think what we're doing now is uploading the local.
Where do I find the local recording?
It handles it for you.
Oh God, yeah, right.
So
Did
now
you
I
refresh, Chris? Because you're still not here in the list.
Well, it's because I haven't hit the refresh button and I got a huge warning and I didn't click through it.
You have to
Yeah.
go through a warning.
I just
No,
did.
look, this is what warnings mean to users. Wah, 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 wah.
Just hit continue and move on. Come on.
All right.
I just did it, and it seemed to have
No,
worked for
Chris,
me.
you're back
so.
now. And you're ready to go.
Unfinalized track.
Then you have to click the button on the track.
You wouldn't see the button unless you hover over it.
Oh, now it
Yes.
says uploading.
Yes, there you go.
That is so freaking scary. I'm sorry.
Living on the edge, man. So, just how about that web browser? How much?
Well, you know what? I guess the browser is a great platform because look I was able to just refresh and it all just worked. They just shouldn't have such a scary warning like, "What are you doing? Why are you leaving?" Ah!
I know.
That's because the internet is broken. It has to tell you you're leaving the page. It's the only way you can do it.
It was their alert. It wasn't the browser.
Weren't we just
No,
talking about affordances?
It was
You
an
got
alert.
triggered because you left the page.
Yeah, but
Scared to death.
Zencaster. Why did Zencaster put up such a scary warning? Why couldn't it say like, "Dude, everything's
Don't worry,
cool.
everything's
Refreshing's awesome."
fine.
Because the UX person didn't say that. Come on.
You can
Yeah,
refresh.
They could have written a thick client and it would have been just as screwy.
What would they write the thick client in? Flash, Silverlight.
Silverlight.
C++.
Some way to do the language. XAML.
C#.
We need XAML on millions of devices.
Make it a UWP app. That way none of us would
Yes.
use it.
Obviously, people want to use the UWP, man.
Oh yes, obviously. You remember at the panel how
Xamarin
many
Evolve
people
was
raised their
very
hands?
was very packed. There were definitely people there.
Yeah, at the panel we're like, so how many of you care about UWP? One person raises their hand.
Nice.
Jeff Fritz is, and Jeff Fritz is like, well, would it help if?
Well, that was our panel.
Nothing would help.
At the Xamarin conference, they were all
Right, at the
They were all
Xamarin
freaking
conference,
annoying.
that's self-selecting. The Xamarin conference is self-selecting.
there are
It's not
people that care though.
How many of you want to use Xamarin?
It's not like they trucked in a million random developers and they're like, oh, you guys love Xamarin. You get us.
Well, keep in mind these people also love XAML, so it all kind of it's all works together. So,
You get a Xamarin.
well, come on, we now have .NET Standard because we have to make Xamarin work in everything too, man.
It's cool. It's
Core
just that
and their standard. Core
I just
and
feel
standard.
like the people who go to Xamarin Evolve, like obviously they like Xamarin. I
yeah,
mean, man,
well, hopefully they do.
you're gonna
They-
you're gonna shell out $3,000. You better like it. It'd be like if I, oh wow, you must really like HoloLens. Yeah, I know. I spent $3,000 on a freaking helmet, right? You must like it. Not me. But
the UWP people, they love it. So they gotta have some platform to actually use it on.
All right,
I felt so stupid when I was on .NET Rocks because Carl like builds it up and he says, so we ask all our guests and Chris Gomez, if you had $5,000 to spend any
Oh,
technology you
come
want,
on.
and this ought to be good, and I'm thinking, oh, that actually wasn't very good. And as soon as the show ended, I was like, oh man, I got a lot of good ideas now. Can we do that again?
Here's where I'm at right now. No, right here. I'm sitting
$5,000.
Is that really where you are?
yeah, I'm in France.
That's pretty
Right now.
cool.
So this is a horrible. Sign here that my track is 1 hour and 28 minutes and Todd's is 1 hour and 52 minutes.
What?
Oh, dang.
Well, no, because we were also talking, right? I
Yeah.
did when I hit refresh, it probably didn't stop recording.
I think so.
I guess that's what must have happened. Is that when I hit
Yes.
stop, you guys didn't get the memo. The message didn't make it through.
There
That's
wasn't.
right.
There wasn't a
Call it
handler.
an IOC container somewhere.
It's
Yeah.
eventually consistent.
Yeah.
It's the web. I had to make a new GET request in order for I to be notified.
So the guest thing worked out pretty well. We should also probably edit Andy's podcast.
Yes,
Somebody
we should.
should do that at some point. Sure.
You know what? We should have Andy do it.
It was the noise, man. The noise was killer.
It was from his noise, right?
Yeah. All right.
All
I'm
right.
just keeping us all on until I
Sounds
see
like-
all the
Sounds like
tracks
we're good
uploaded.
anyway. Yeah, right. Exactly. Not that I'm sure what we would do about it at this point.
All right. I'm going to stop broadcasting at least.